Okay, so in this video we're looking at problem 3 from the exam. So in this problem we're asked to first state the definition of derivative. So the definition of derivative says that f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h. So for the function 1 over the square root of x, this gives us the limit as h goes to 0, 1 over square root x plus h minus 1 over square root x, all divided by h. So there's a few different ways to approach this problem. The way I think is easiest is to first try to combine these fractions in the numerator by finding a common denominator. So in order to find a common denominator, we have to multiply the first function by square root of x over square root of x, and the second function by square root x plus h divided by square root x plus h, which gives us square root x minus square root x plus h over square root x plus h. And this is all still divided by h. If we do some simplifications on this, we get this is the limit as h goes to 0, square root x minus square root x plus h over h square root x plus h. So now we have these square roots in the numerator that we'd like to get rid of. So we multiply by square root x plus h in both numerator and denominator in order to clear the square roots from the numerator. So we're basically rationalizing the numerator. So we multiply by square root x plus h. And when we do that, we'll get the limit as h goes to 0 of x minus x plus h over h square root x plus h times this thing that we multiplied by square root x plus h. And now the reason why this helps us is we have a negative x minus x. The x's in the numerator cancel. I'm left over with limit as h goes to 0, negative h over h square root x plus h times square root x plus h. And now we see there's a negative h in the numerator and h in the denominator. Those h's can cancel. So we get limit as h goes to 0 of negative 1 over square root x plus h times square root x plus h. And now the denominator no longer goes to 0 as h goes to 0. The numerator doesn't go to 0. So this is a continuous function. We can just plug in h. Okay, I guess the numerator going to 0 or not doesn't matter for being continuous. The important thing is that the denominator does not go to 0. So that means the function is continuous. So we can just plug in h equals 0. And that gives us negative 1 divided by square root x times square root x times 2 square root x, which gives us negative 1 over 2 x to the 3/2 power. And this is, in fact, the same result that you would get if you were to apply the power rule to this function. So we get the result that we expected.